Hello and welcome to Note Quiz number 5. In this video, we're going to go through and work through a bunch of problems about defining what a function is, and we're going to be looking at lines and circles and some basic point plotting. So for this first problem, we want to plot several ordered pairs and see where they are on a graph. So before we get started with that, we want to talk a little bit about conventions, and the idea again is that when you see an ordered pair with the x and the y number, the x is the horizontal location. Positive x's are on the right side of the graph, negative x's are on the left side of the graph, and the y's are the vertical. Positive y's are up above the axis, and the negative y's are below the axis. And just for review purposes, this is our x-axis right here going again side to side, and this is our y-axis here going above and below. And finally, we call this the first quadrant. This is the second quadrant. This is the third quadrant here, and finally, this is the fourth quadrant. So let's go ahead now and plot these points. So for our first ordered pair, we've got -2, -3. So that's going to be 2 to the left and 3 down. So going 2 left and 3 down, we're going to be right here. Again, that's our -2, -3. For our next ordered pair, we're going to have 5/3 and 7/2. Well, 5/3 is going to be 1 2/3. So that's going to be 1 2/3 of the way between 1 and 2. And then 7/2 is 3.5. So that's going to be, again, at 1 2/3 and 3.5 puts us right around there. So this is the ordered pair B. And rather than writing out the actual numbers, I'll just put a B there to represent that spot. For ordered pair C, that's going to be -2.2, which is a little bit left of the -2, and 2.9, which is just a little short of 3. So that's going to be right around here for ordered pair C, over here in the second quadrant. And then the last two ordered pairs, well, they're going to be sitting on the axes. Pi, 0 is 3.14, 0, which is just a little bit past 3. So that's going to be right here on the x-axis. And again, that is going to be ordered pair D. And then finally, ordered pair E is 0, square root 7. The square root of 7 is right between 2 and 3, perhaps a little closer to 3. So that's going to be right up here. And that is ordered pair E. So again, our ordered pairs, if we go back and rewrite to be consistent, are found by counting how many spaces to the left or right for the first number, and then how many spaces up or down for the second number. All right, now let's move on to solutions and equations. If you look at these ordered pairs, the idea is that if an ordered pair makes the equation true, then that ordered pair is on the graph of the equation, and it's a solution of the algebraic equation. So for these problems here, we want to substitute in the pair and see if we get a true or false statement. So again, the equation given to us is x squared plus y is equal to 1. So for the first one, we're going to take x is -6. So it's going to be -6 squared plus the y number, which is -45. And we want to see what that equals out to. Well, -6 squared we know is 36, and -45 is, well, -45. Adding them together, that's going to make a -9, and that -9 is not equal to 1. So the answer is no, that point is not a solution of that equation. Now let's move on to the next one. Again, it's still x squared plus y equals 1 that we're trying to check. Taking that ordered pair, we've got x is 1/2, so that's 1/2 squared, plus the y number, which was given as 3/4. 1/2 squared is 1/4, 3/4. They do add up to make 1, so that ordered pair checks out. And the answer is yes, that ordered pair is a solution of that equation. For the last one, again, same equation, x squared plus y equals 1. The x squared is going to be the number 7 squared plus the number -48. 7 squared is 49, minus 48 does make 1. So this also checks out, and we say that the ordered pair is a solution of the algebraic equation. So again, that's how we check to see whether or not we have a solution of an equation given by an ordered pair. And remember, the graph of this equation is the set of all solutions of the equation. All right, so let's move on now to the next page. For this next page, we want to plot some points. Okay, so we want to graph the equation y equals negative 2x squared by plotting points. And so the idea is to always pick points that you think are going to show up visually on the graph. And again, picking x values way too large are not going to appear on the graph because sometimes they can calculate or determine y's that are too large. You also want to stay away from fractions and decimals because again, they're a little more tougher to compute and they're hard to graph. So for this one, we're going to pick a total of 5 x values. We're going to pick a negative 2, a negative 1, a 0, a 1, and a 2. And the idea is that we can go through and calculate these. You'll notice they're in a row, and that's very important as well because it helps gives us a complete picture near the origin. And so now let's go through and substitute. We're going to have negative 2 times, and there's really no space to show that work in there, so we'll just kind of go through the steps here. If you take a negative 2 and square it, you get 4. So this is going to be negative 2 times negative 2 squared. So that's going to calculate out to be negative 8. So negative 2, negative 8 is our ordered pair. Substituting in negative 1, negative 1 squared is positive 1 times negative 2. So that's negative 2 times negative 1 squared. So that's the ordered pair negative 1, comma, negative 2. When you substitute in 0, and you square it, and you multiply by negative 2, you actually get the value of 0 back again. So this passes through 0, 0, 0, 0, the origin. Substituting in 1, we have negative 2 times 1 squared. That's going to make a negative 2 like we had before for the negative 1. And then finally, plugging in 2 again, it's readily easy to see that we get negative 8 again. Because 2 squared is 4, and negative 2 times 4 is negative 8. So now we plot these ordered pairs. We saw we have 0, 0. We saw we had 1, 2 on the right. We had negative 1, positive 2 on the left. Sadly, 2 corresponds to... Actually, those are down below. Let me erase those. It's my bad. So going back, those are actually down here, right? So yeah, there's negative 2. All right, and again, you will notice that when we graph these, we can't go to 2, negative 8 because it's off the chart, and so is our negative 2, negative 8. So the best we can do for this graph is something like this here, where we get a nice upside down U shape. And again, we'll be calling those parabolas because of the x squared, giving us the graph of a parabola. And again, we'll be doing a lot with those this semester in this class. All right, so now let's move on to the next problem, which is all about finding intercepts. If you think back to previous algebra courses you might have had, for finding intercepts, the idea is you set the other number and the ordered pair equal to 0. So in other words, if you want to find the y-intercept, you set the x equal to 0. And to find the x-intercept, you set the y equal to 0. So for this first one, we do that. We're going to have 2 times 0 minus 8 times y equals 16. That's just negative 8y equals 16. Divided by negative 8. And you get y equals negative 2. Now to get the x-intercept, we're going to set the y equal to 0. That's going to give us 2 times x minus 8 times 0 equals 16. That's going to give us 2x equals 16, or x is equal to 8. So the x-intercept is going to be 8, 0. Don't forget it's always an ordered pair. The y-intercept is going to be 0, negative 2. For this next equation, we're going to have a similar calculation, except a little bit more algebra to do. So again, y-intercept we're going to set the x equal to 0. So that's going to be 0 equals negative y plus 16. That makes the y equal to 16. So that ordered pair for the y-intercept is going to be 0, comma 16. Now to get our x-intercept, I'm going to be a little careful here and put a parenthesis with an s because there's actually two of them. We're going to set that y equal to 0, and that gives us x squared is equal to negative 0 plus 16, or just x squared equals 16. We saw in previous notes that if you take the square root of both sides of this, you get two solutions. We get x equals plus or minus 4. So there's actually two x-intercepts. There's negative 4, 0, and there is 4, 0 for this equation. So remember, it's always possible to have multiple x-intercepts. Y-intercepts will not happen when you have what's called a function. All right, so next up, we're going to go through and look at the center and radius of a circle. The standard form for a circle is always x minus h squared plus y minus k squared equals r squared. And you'll notice that there's a minus that's embedded in the formula. So some people like to say we take the opposite. So in this case here, we have the h and the k making up the center, and r is the radius. So the center is going to be a positive 7 and a negative 6. Because we always look at the opposite. So again, in the first, that's a 7 there for h, and that's a negative 6 for the k. The radius is the square root of the lonely number on the other side. So that's going to be a 7, because 7 squared is 49. And that is the two features. Now, rather than looking at Desmos and graphing this, because we're using an iPad here and we can't pull up both simultaneously, the idea here would be that when you graph this in Desmos, you would see a circle with a center at 7, negative 6, and a radius of 7. Right, so now let's move on to the next page. And the next page has us looking at more circles. All right, so once again, we'll write down our formula for the standard equation of a circle. And again, that formula is always x minus h squared plus y minus k squared equals r squared. So for this problem here, with a center given to us as negative 4, 1, we know the h number is negative 4 and the k number is 1, and r is going to be equal to 1. So putting that all together, we're going to have x minus a negative 4, which is x plus 4 squared, plus y minus k, so it's y minus 1 squared, equals 1 squared, which is just 1. So again, the idea is there just to write the equation out from the given information. Now we're going to move on to the next problem. And the next problem has us actually doing some constructing. They want us to find the equation for a circle given the endpoints of its diameter. To do that, we're going to find the center. And the center is the same exact thing as the midpoint of the line going through the circle. So here's our center. And for a quick sketch of what's happening here, let's draw kind of a quick little circle and see what we're doing. So again, the endpoints of diameter are the two ordered pairs given to us here. If we draw a line going through the circle, it's going to pass through that radius, which again is the center of the circle, which is midway between those 2 points. The distance formula can be used to find the distance from the outside to the inside. So you can either find the distance all the way across the circle, which is your diameter, and then we're going to have to cut that in half to get our radius. So let's go through now and put this together. So for starters, let's get our center. So our center is going to be that midpoint. And it doesn't matter how we label the points as long as we're consistent. So let's label this one x1, y1, that's one, x2, y2. So the center is going to be the sum of the x numbers. So that's -5 plus 1 divided by 2, comma, the sum of the y numbers, which is 2 plus 10 divided by 2. If we simplify that out, we're going to have a -4 over 2 and a 12 over 2, which simplifies down to a -2, comma 6. So that's the center of our circle, which is the midpoint of the line segment between the two endpoints. Now let's find our diameter. For the diameter, we're going to use our distance formula. And again, that's the square root of the squares of the square root of the sums of the squares of the differences. Better yet, that's just the difference in the y numbers. So that's 10 minus 2 squared plus the difference in the x numbers, which is 1 minus -5 squared. We can calculate that out. We know that 10 minus 2 is just 8. 1 minus a -5 is just a 6 squared. So that's the square root of 64 plus 36, which is the square root of 100, which is equal to 10. Now be careful, that is the diameter of the circle. The radius r is going to be 1/2 of that. So that's 1/2 of the 10, which we know is 5. So we now have our center. We've got our radius. We are ready to write that equation. Our equation is going to be x minus -2, so x plus 2 squared, plus y minus 6 squared equals 5 squared, which is 25. And that is the equation for our circle, which has these features. All right, now let's move on to the last problem for circles. For this one, you'll notice that it is written in a, I won't say scrambled form, but it's written in a form that is a little more challenging to work with. It doesn't have the quantities in squares and parentheses. So what we're going to do is complete the square for both the x's and the y's to put it into the standard form. The first thing we should do in doing this calculation is to rewrite it. So we've got the x squared first. And then we're going to write down the minus 14x behind it, and then leave some space. And then plus the y squared minus the 2y behind it, leave some space. And we're going to move that 34 over to the other side as a -34 by subtracting it from both sides. All right, now we're going to complete the square. And to complete the square, we're going to do what we did in previous notes, which is to take half of that b number, square it, and add it to both sides. So half of -14 is -7, and -7 squared is 49. So we're going to add 49 onto both sides to take care of the x's. And then we're going to focus on the y's. We're going to take half of the -2 and square it and add it to both sides. Well, half of -2 is -1. -1 squared is 1. So we're going to add a 1 onto both sides of the equation. We can now factor the first 3 as just x minus 7 squared. We can then factor the next 3 as y minus 1 squared. And then over there, if we take 49 and subtract 34, that makes it, looks like, let's see here, 15. And then 15 plus 1 makes 16. So we have an x minus 7 squared plus y minus 1 squared equals 16 for our equation in standard form. The center we know is going to be 7 and 1. Actually, it's going to be, let's see here. No, they're both minus, aren't they? Yeah, so 7 and 1. And the radius is going to be 4, the square root of the 16. So that is our equation taken from a multiplied out expanded form into the standard form. All right, so now let's move on to the next page. And now we're going to talk about functions. All right, so let's talk now about functions. And the idea here is that when you're defining a function, we want to have the convention that each of our x numbers, or we say for each x, there is exactly one y. And so visually, that looks like what's called the vertical line test, because the idea is if you pick any x on the x-axis and go up or down, it's going to hit the graph in only one spot. And if it hit in more than one spot, then you would be having more than one correspondence. So for the first one, you will notice that no matter where I draw a vertical line, I'm going to only hit one point. So we're going to say this is a function, and it's always good to say that it passes the vertical line test. For the other one, you will quickly notice that if I draw a line anywhere on the right side of it, or even the y-axis itself, it's going to intersect in 3 spots, and sometimes 2, sometimes 1, but again, you have to be able to draw a vertical line anywhere in the graph and just hit in 1 spot or less. So this is not a function. Let me say that this one fails the vertical line test. So again, when you're given a graph of a relation and you're trying to find out if it's a function, you can apply the vertical line test and see if it crosses in more than one spot. All right, now let's move on to relations given to us as equations. You will notice that the first one is y equals mx plus b form. We know that's going to be a line, and we see that the slope is equal to 3. So because of that, a line that's graphed is going to pass the vertical line test as long as it's not an actual vertical line itself. And it's not vertical because we have a slope of 3 there. For the next one, we can isolate the y. Y is equal to x squared plus 4. The graph of that is going to be a parabola. And because of that, it is going to pass the vertical line test and be a function. And it's a parabola, you'll see soon, that opens upwards, like so. The last one, well, hopefully you're remembering something we talked about a few minutes ago. That is the graph of a circle. And if you think about a circle, it is definitely going to fail that vertical line test. And so that is going to not be a function. All right, so again, lines that are not vertical, they're functions. Parabolas that open upwards or downwards, they're functions. Things like circles are definitely not functions. All right, so now let's move on to evaluating functions, and that's just finding y values that correspond to a given x number. So for the first one, they want us to find h of 2. When you use function notation, the number inside the parentheses is the x. So when you find h of 2, you're going to replace all the x's in the formula with a 2. So that's 3 times 2 squared plus 2 times 2, which we can calculate as 3 times 4 plus 4 more. So that's 12 plus 4. That's going to make 14. And it should be noted that the number that you get, that is the y number, which is the second part of the ordered pair on a graph. For the next one, they want us to find f of negative 10. Finding f of negative 10, we once again substitute in negative 10 in place of x. In doing so, we get the square root of negative 4, which is not a real number. And when you're dealing with functions, we're not looking at anything being imaginary or complex, just real, strictly real. So therefore, we're going to say that this function value is just undefined. We can't find it. And what that means visually is if you look at a graph of this thing and went over to where x is negative 10, there's no corresponding y values. All right, let's move on to the next one. G of x equals -5. And we'll kind of write it down here underneath it. You will notice that for this function, the y number is always locked in at -5, no matter what I put in place of x. So in particular, when I find g of 6, I'm also going to get -5 for the answer. We refer to these things as constant functions because they always give us the same value out. They're constant, they're not changing. All right, and finally over here for number 15, they want us to find f of 10. That's again replacing the x's with 10s in the formula. That's 5 divided by 10, which we know is just 1/2. All right, so again, function evaluation is just replacing the x's in the function notation with whatever x number they give you to work with. All right, so let's move on to the next. And the next page has us finding more function values, but this time it's for more complicated expressions for the inputs. All right, so for this first function, they want us to find g of a plus 5 for the function g of x equals 2x plus 3. Another way of thinking about functions is that they're going to perform operations. So this function is going to take whatever you substitute into it and multiply it by 2 and then add on a 3. It's going to do the same thing to a plus 5. It's going to take that a plus 5 and multiply it by a 2 and add 3 to the final answer. If we simplify this down, that's 2a plus 10 plus 3. That's going to be 2a plus 13. The same thing is going to happen for the next problem. We're going to go through and find f of x plus h. When you see function notation, you might find it helpful if you're really new to it to rewrite it with a symbol like a box. So f of box would just be 4 times whatever is in the box minus 2 times whatever's in the box squared. So when you find f of x plus h, it's going to do the same thing. It's going to give you 4 times the x plus h minus 2 times the x plus h quantity squared, which we can simplify down just using some algebra. We know that's 4x plus 4h by distributing. That's minus 2, and then x plus h needs to be FOILed out because you're squaring two things added. So that's 4x. I said that was 4h. That should be an h right there, right? All right, so that's going to be a 4h. And then you're going to have a minus 2 times x squared plus xh plus xh plus h squared. Running out of space, that's 4x plus 4h minus 2 times x squared. The inside, these combine to make 2xh times that extra -2 makes minus 4xh minus 2h squared. So that's what you get for that function. You get a 4x plus a 4h minus 2x squared minus 4xh minus 2h squared. And in coming weeks, we'll be doing something with these. All right, next up, we're going to talk about domain and range coming from graphs. And this is a very visual process. The domain is always the x values for the graph. In fact, let's write that over here off to the side. So the domain is the x values, and the range is the y values. So when you use a graph to find these things, you have to look at what's happening as you travel different directions. For domain, it's always going from left to right. You notice for this first one, the arrow points that it goes on forever. So as you travel along this graph, you'll notice there's no breaks at all. It just goes forever in both directions. Because of that, the domain is all real numbers. The graph is defined everywhere. The range, however, you will notice that it goes down forever. So it's going to go down this way forever, and then it continues up right until you reach a 3, and it stops. And it does include the 3 because that's a filled in dot there at that point of that triangle. So the range is going to start down at negative infinity, but it's going to end up at 3. Infinities, again, are always around parentheses. The 3 is included because there's no open circle there to say it's excluded. For the next problem, if you look at the range and the domain it goes from left to right. The arrow on the parabola suggests that it goes forever that way. The arrow on this part says it goes forever in that direction. You'll notice there's no places where there's holes in this graph. There's no things missing in it. There's no jumps or breaks in it. So the domain is once again all real numbers. The range this time starts down here at negative 3 and goes up forever. And again, the arrow there really doesn't belong on that. The idea is that it starts at the point of negative 3 down here and goes up forever. So the lowest value I'm going to get is a negative 3. Going up forever means it goes to infinity. And once again, since I can get the value of negative 3, I put a square bracket on that number. All right, let's move on to the next page. Next page has us finding domains and ranges from formulas. And this is a little different than finding them from graphs. When you're finding domains from the graphs, what you want to do is always kind of play devil's advocate, which is asking what can go wrong. Well, if you think about it, you can, for this first one, you can multiply any number you want by a 4, and you can add 8 to any number that you want as well. So there's no restrictions at all. So because of that, the domain is going to be all real numbers. There's no restrictions whatsoever. Moving on to the next one, however, you notice that we have a square root. We know that we can only take square roots of things that are greater than or equal to 0. So we're going to set what's inside the square root to be greater than or equal to 0. And then that gives us a little tiny equation to solve. And we see that the t's must be greater than or equal to negative 2. Remember, domains are intervals or sets of numbers. So it's going to start at negative 2 and go to infinity and include the negative 2. And that's true for any square roots or fourth roots or any other even roots. If this was a cube root problem or a fifth root problem, it'd be all real numbers because odd roots don't have restrictions. All right, moving on to the last one. This is a rational function. Remember that we don't want to divide by 0 with rational functions. So we want to make sure that that 4t plus 8 is not equal to 0, which means that 4t can't be negative 8, and dividing by 4, that says that t can't be equal to negative 2. Now, if you think about this on a number line, this is basically saying to us that negative 2 is the one number you don't want to use, and everything else is perfectly fine. So remember, the domain are the numbers you're allowed to use. So because of that, the domain is going to start at negative infinity up to negative 2. And we want to use a parenthesis on the negative 2 to exclude it. Union negative 2 to infinity. So it's the entire number line with the exception of the number negative 2. Kind of think of it as just a hole being punched out at negative 2. All right, so that's going to be true for any division function. You'll notice that we completely ignore the numerator in that process. We don't care about the top of the fraction. It can be 0. It's the bottom of the fraction that matters. All right, now let's move on to more graph reading. When you're reading graphs, you want to remember again that the number inside of the function notation, that is the x number, and the calculated answer is the y number. So when you want to find f of negative 4, you find negative 4 on the x-axis and go up to the value and read it off. And it should be pretty obvious that if you find x is negative 4, the y number is up at 2. For the next one, we want to find f of negative 2. That's once again finding negative 2 on the x-axis and either going up or down. If you go up there, you see an open circle. Remember, open circles are exclusion. Instead, you go down to where it's filled in and read it off, and that is -4. So -4 is the one function value. Keep in mind again, you are not going to have multiple answers here because functions only give you one corresponding y number. So again, one answer. However, for the next questions, those are sometimes called the backwards question. They're giving you the y, and they want you to find the corresponding x. To do these, the easiest thing to do is to find that number on the y-axis, which is right here at -1, and then draw a little line across and read off all the x's that brought you there. If you go up to the first one, it looks like it's -1. Next one looks like +1. The last one looks like 5. So you have -1, +1, and 5. You can have multiple answers on questions like this. For the next one, they want you to now focus on f of x being -4, which again means that you're looking at y being -4. Go down to -4, down here, you'll see it happens twice. It happens when x is -2, and it happens when x is +2. So -2 and 2 both bring you there. And again, those aren't ordered pairs. Those are just the x locations where it happens to give you a y value of -4. Finally, they're going to ask you on this page about the y-intercepts. And the y-intercept is where it crosses on the y-axis. You're only going to have, actually, what am I saying? It's the x-intercepts for this one. Sheesh. So if you look at the x-intercepts, that's where you're crossing the x-axis. It's always good to read these very carefully. So we cross the x-axis here at the origin and over here at 6. Remember, these are ordered pairs because they're locations on the graph. So 0, 0, and 6, 0 are those two x-intercepts. And again, it is possible to have multiple x-intercepts for the graph of a function. All right, now let's move on to the next page. The graph isn't on the next page, so you're going to have to remember the picture or go back to it. Maybe look at the PDF while you're answering the question. They also want you to find the y-intercept from that picture. And we saw earlier that it crossed through 0, 0. So in that case, the x and y-intercept are exactly the same. So 0, 0 is my y-intercept. Again, you will only have one answer for y-intercept questions. It is impossible to have more than one. Now we want to find the domain. Again, looking at the picture on the previous page, you'll notice that the graph starts at the far left with an arrow there. And as you connect from left to right, you'll notice that there's no x's missing. There is a break in the graph at -2, but there's a dot down below it, which means it continues right on through and goes all the way over to the far right or infinity. The range, however, you'll notice that it starts down at -4, and it includes it with both the dot and the filled in pointy part. So it's going to be a square bracket at -4. And it's going to continue up to at least the origin, but then you'll notice there's an arrow pointing to the right going upwards forever. So there's no end for y values. You can get as many large y values as you want. So that's the range. And again, you'll have to look at the PDF to see the graph for this page of the note quiz. All right, so now let's move on to more questions. For problem 22, they want us to graph the equation and find the intercepts. So remember again, x-intercepts. You set the y equal to 0. So for this one, it's going to be x plus 2 times 0 equals 4. Tells us that x is equal to 4. So the x-intercept is 4, 0. Now for the y-intercept, we're going to set the x equal to 0. That's going to give us 0 plus 2y equals 4. Divide both sides by 2. And we get y is equal to 2. So 0, 2 is my y-intercept. So on my graph, My x-intercept is 4, 0, which is right there. My y-intercept is 0, 2, which is right there. And my line is going to pass through those 2 points. So there's a nice sketch of that line. All right, moving on to the next problem. We need to find the slope of the line passing through 2 points. Remember your slope formula. Your m is your change in y over your change in x, or your rise over your run. Algebraically, that's y2 minus y1 over x2 minus x1. Again, when you label points, it does not matter how you do it as long as you are consistent. So we're going to call the first one x1, y1, second one x2, y2. Substituting those in, y2 is 7, y1 is 6, down below, x2 is negative 5, the minus is part of the formula, and then we've got a minus 7, or negative 7. So 7 minus 6 is 1, negative 5 plus 7 is going to be 2, so our slope is the fraction 1/2. Which means we see a rise of 1 and a run of 2 on the graph of this function. All right, moving along to the next page. They now want us to read the slope of the line from a given graph. The easiest way to do this is to find a nice point on the line, which looks like it's right here. And then we want to travel to another nice point on the graph. You'll notice it's right over here, another nice intersection of the grid. So remember, it's rise over run. So we're going 1 up, 2 up, 3 up. So my slope is going to have a rise of plus 3 because we went up 3. The run is to the right. Again, that's the positive direction. It was 2 to the right. So my slope is a positive 3 over 2. It should be noted here that if you missed that point and went all the way up to here instead, you would just have larger numbers in your fraction that you could reduce and still get 3/2 for your slope. You'd actually get 6/4. But again, 6/4 reduces down to 3/2. All right, next up, they want us to put the equation into slope-intercept form and find the slope and the y-intercept. So this is really a quick calculation, and the amount of space here really isn't fair for the problem because we don't need this much, but we will go ahead and just kind of follow through the problem. So the first thing you want to do is just write the equation down as written. So 2x minus y equals negative 2. We now want to isolate the y. So we're going to subtract 2x from both sides. And in doing so, we get negative y equals negative 2x plus 2. You'll notice I put the x term in front because we want to use the slope-intercept form. And then we're going to divide both sides by negative 1. So my y is equal to, it's like positive 2x. And that was a minus 2, by the way, so I knew that was wrong. So that was a minus 2 originally. So let's put that back where it belongs. And then when you divide by a negative 1, that's going to become plus 2. Remember again, it's y equals mx plus b. M is the slope. And b is your y-intercept. As an ordered pair, it's 0, comma b. So the equation in slope-intercept form is y is equal to 2x plus 2. The slope is m equals 2, and the y-intercept is 0, comma 2. So we have two different 2's with different meanings here in this problem. All right, let's move on to the next page. The next page has us graphing two different lines and then using the lines to answer some inequalities. So we're going to do these in two different colors. We're going to first graph the first one in red. So in red, I'm going to have my y is equal to x minus 3. That has a y-intercept of negative 3 and a slope of 1. So that red line is going to pass through these points here. The next one, I'm going to do it in blue. So that's y equals 2x minus 5. That y-intercept is -5, and the slope is 2, which means I'm going to rise up 2 and go over 1 to the right. And I'm going to put that on here a few times, up to, there we go, up to right 1. Did I just miss? No, up to, yeah, my line is a little off there, isn't it? So this one's going to go up this way, and we don't have to be too perfect with this because the most important point on this graph is going to be that intersection point right there, which will make extra big. All right, so the idea is, again, if you think back to the first part of this note quiz, all the points on the blue graph make the blue equation true. All the points on the red graph make the red equation true. And the points where they cross are going to be where they make both equations true, which means the y numbers are equal to each other. So that location or that solution to that equation is going to be x is equal to 2, because that's the location where the two lines cross. For the next one, they want to see when x minus 3 is less than 2x minus 5. Sometimes it's helpful to label the actual lines with the equations. So when x minus 3 is less than 2x minus 5, they're asking you when is the red underneath the blue one, because the x value, we want the y values of the red one to be smaller than the y values of the blue one. So red is under blue when you are on the right side of the graph. So those are going to start at 2 and go on forever. Because we have a strict less than, it is a parenthesis there. And of course, the infinity symbols, they're always going to be that way. The last one is asking when this is reversed. In other words, when is the red one above the blue one? And that starts on the far left of the graph and ends at 2. And you'll notice because of the equals bar, we want to have a square bracket on the 2. So you can use the graphs of lines to solve inequalities by looking at whether something is above or below it, which is pretty nice. All right, now we're going to talk about building lines from information. This first one wants us to use what's called the point slope formula. That formula is y minus y1 equals m times x minus x1, where m is your slope and x1, y1 is your ordered pair they give you. So for this one, we're going to have y minus the y value, which is 7, is equals the m, which is 4, times x minus -1, which is x plus 1. Now they want the answer in slope-intercept form, which is, again, y equals mx plus b form. So we have to do a little bit of multiplying here. We're going to first have y minus 7 equals 4x plus 4. Then we're going to add the 7 to both sides. And we get the answer that y is equal to 4x plus 11. And so that's the line that we built from that information. All right, let's move on to the next page, and we will pause things here. Okay, so moving on to the next page. Plus, eek, we just went backwards on the previous page. Let's fix that. We are going to be looking at finding equations of lines under different conditions. The first one is going to be finding an equation for a line that's given passing through 2 points. So the first thing we want to do in this problem is to write down our slope formula, which we know, which is m is equal to y2 minus y1 times x2 minus x1. And again, we will label the first point x1, y1, second point x2, y2. Now substituting those numbers in, we're going to have 2 minus 4 over top of 3 minus -1. So 2 minus 4 we know is -2. 3 minus a negative 1 is 3 plus 1, so that's 4. Reduces down to negative 1/2. We now recall the point slope formula. And the point slope formula is y minus y1 equals m times x minus x1. And again, we could pick either one of these 2 points up here to use in it, but let's just kind of go ahead and use the one that's labeled already with x1 and y1. So you got y minus the 4 is equal to negative 1/2 times x plus 1. So y minus 4 equals negative 1/2 x minus 1/2. We then add 3 to both sides. And we got y is equal to negative 1/2 x plus 3 minus 1/2. We can rewrite that 3 as 6/2 by multiplying by 2 over 2. So y is equal to negative 1/2 x plus 6 over 2 minus 1 over 2. So y is equal to negative 1/2 x plus 5/2. All right, and again, they wanted this answer in slope-intercept form, so that again, that's that y equals mx plus b form that we want. All right, for the next 2 problems, they want us to go through and they want us to find a line parallel to a given line, and they want us to find later a line perpendicular to a given line. In both problems, the first thing we have to do is take the original equation for the line and solve for y. Then you have 5x plus y equaling negative 5, subtracting the 5x from both sides. You get y is equal to negative 5x minus 5. For this problem, it's a coincidence that both the slope and y-intercept are the same, but remember the slope is always the coefficient on the x, so the m that we want is negative 5. Now, because we want to have a line that is parallel, that means we want to have the same slope. So for our new line, we're also going to take m equal to negative 5, and then substitute that into the point slope formula. So again, it's y minus y1 equals m times x minus x1. So that's y minus 4 equals negative 5 times x minus negative 1, which is plus 1. So y minus 4 equals negative 5x minus 5. Adding 4 onto both sides, we get y is equal to negative 5x minus 1. And that is the equation for the line that is parallel to the given line through that point. And again, you could go to a graphing calculator or Desmos and graph them together and see that they are, in fact, parallel. For the next problem, we're going to look at a perpendicular line. So for this one, we're going to once again take the original equation for a line, and we're going to solve for y. So x minus 5y equals 5. Subtract x from both sides. So negative 5y is equal to negative x plus 5. We're not done because we need to have the y by itself. Divide both sides by negative 5. And y is equal to 1/5 x minus 1. So that's the original equation for the line. M is 1/5. But now we want the perpendicular slope. Sometimes written m with the little perpendicular symbol. Going back up, remember that the perpendicular line is going to have a slope that is the negative reciprocal. So you have to flip over 1/5 and get 5 and multiply by a negative 1. So negative 5 happens to be our slope for this problem. And then once again, we're going to run it through the point slope formula. So that's going to be y minus y1 equals m times x minus x1, which is y plus 1, because it's minus my negative 1, equals negative 5 times x minus 3. So y plus 1 equals negative 5x plus 15. Subtract 1, and our line is y is equal to negative 5x plus 14. And again, that is the equation for the line that is perpendicular to the other line. And again, the visual to have in mind here is that these two lines are going to cross at a 90-degree angle. If I can draw better 90 than that, there we go. So 90-degree angle when they cross. And again, you can check this on Desmos or in a graphing calculator and see that they cross in a perpendicular way. All right, so let's move on to the next page. And the next page is going to be some application problems. So for the first one, they want us to write a formula that models a person's salary. We have a salesperson making a base salary of $300 per week. On top of that, they're going to get a $13% commission on their sales. So what we ought to do here is think about how to model their salary. And this naturally lends itself to the slope-intercept, I should say, form of a line. Because they're always going to get paid $300, so that's always going to be part of their salary. And since they're getting 13% of their sales paid back as their salary, you're going to have your X as being the dollars in sales. So we're going to take that number and multiply by 13%, which is 0.13. So our Y is going to be 0.13x. Again, that's the 13% commission on sales plus the $300 that they get paid, regardless of selling anything. And now because they want us to find a function, and they want us to call it S of x, because that's salary, S of x is going to be 0.13x plus 300. And it should be noted here that, again, if you plug in 0 for x, you have $300 of income. And for each dollar you sell, you're going to get 13 cents. All right, so next up, they want us to calculate S of 7,000. And again, that's just substituting it in. So that's 0.013 times 7,000 plus 300. And when you calculate that out, you should get an answer of 1,210. And the idea is that if you sell $7,000 worth of, let's just say items or sales, we'll say items, then you will be paid $1,200. $1,210. Don't forget your $10. Every dollar matters, right? That week. All right, so now we're going to talk about a different kind of problem, which talks about costs, profits, and revenues. So we have a small business owner who's going to be making some cookies and selling them at a farmer's market. The fixed cost they have to pay out every single month is $700. And then they have to pay an extra 29 cents per cookie in sales to produce the cookies. Think about flour, labor, all that kind of stuff. And then they're going to turn around and charge $6 per dozen for their cookies. So what we're going to do here is we need to define a variable. And you notice there's kind of a catchy thing. We've got 29 cents per cookie, but we also are talking about dozens of cookies. So the easiest and smartest thing to do here is to let your variable X represent 1 dozen cookies. And if you do that, then your 29 cents per cookie times 12 will give you the cost per dozen cookies, which is going to be $3.48. So It's going to cost us $3.48 to make a dozen cookies. So now let's model our cost function. We know that no matter what we do every month, we gotta pay $700. And then it's gonna cost us on top of that $3.48 for every dozen that we sell. So our cost function is 3.48x plus 700. And again, that's the money we have to pay out to produce X dozen cookies. Now we're going to talk about revenue. And you don't want to confuse revenue with profits. Revenue is the money that you're bringing in at the end of the day in sales. Think of it as just money in your cash register when you're done, or total sales sitting inside of your iPad if you're selling, more with a more modern approach. So the revenue function is really easy to find. We know that we're going to be getting paid $6 or charging $6 for every dozen cookies. So if you sell 1 dozen, you make $6. If you sell 2 dozen, you get $12. 3 dozen makes 18, and so on. So 6x is our simple revenue function. Now the next thing we're going to do is talk about the profit function. And we know that profit is always the difference between the cost you're paying out and the money you're bringing in. So for this problem, we find our profit function. It always has the formula of P of x is equal to R of x minus C of x. Again, your profits is the difference between revenue and cost you're paying out. So for our problem, the revenue we know is $6 per dozen. And we know that our cost function was 3.48 x plus $700. That's really a 6x and then minus 3.48x. Don't forget to distribute your negative, minus 700. So when I combine like terms, my revenue function, profit function is 2.52x minus 700. And you'll notice that if I sell 0 dozen cookies, I'm in the hole $700 because that's the amount of profit I have, a negative 700. All right, so next up, they want us to find out how many cookies we have to sell to break even, to make a profit. So we want to have our profit to be strictly greater than 0, which means we're solving 2.52x minus 700, strictly greater than 0. That's a really easy inequality to solve. We just add 700 to both sides, and then divide both sides by the 2.52. And that's going to take us to x being greater than, and we do get a decimal number. We get 277.8 if we round to the tenths place. And again, we have to have more than that to get a profit. So we actually need to sell 278 dozen of those cookies to get that to break even. It's a lot of cookies, but we can do it. The last part of this question is now asking how much we make if we sell 110 dozen cookies. That's just the profit for 110. Substituting that in, that's 2.52 times 110 minus 700. And that comes out to be, sadly, a negative number. It's negative, I put the negative in front of the dollar sign. It looks a little better. It's going to be a negative 422.8, which means that we are going to have a loss of $423, or actually, it says round to the nearest cent, so let's be consistent with our directions. That's going to be negative 422.80 cents. So again, we are going to have a loss of $422 that month if we only sell 110 of our cookies. All right, now let's move on to another application, and the next application is going to be using tables of numbers to find relationships between variables. So this has us looking at hamburger calories and cholesterol. And we're going to have to turn the page, of course, to make this fit. So the table, again, will be on one side. Our work would be on the other. Again, if you can pull up the PDF document of the notes and put that here, that would be extremely helpful for us. So the first thing they want us to do here is do a scatter plot of the points. And a scatter plot is just us going in and plotting the points to the best of our ability. Again, it's unfortunate that the points are on the other page, but if I copy them down from the PDF and plot them, I will have the following graph. So I'll have a 210 corresponding to, it looks like a 35. So that's a little past the 200, and in between the 30 and the 40. Then I get to the 400 line, and I'm going to have 2 points there sitting at the 50, right around there or so. And then another point a little higher up, right there. And then another point that is going to be up here on the midline or so of this. Another one that's down a little bit over here. Another one that is up as 105, and it's over just short of 600. So right around there or so. And then I've got a point over at a little past 790. So 790 is about there. And then there's another point sitting right around there. So that's us plotting those points. And again, I just used the PDF picture to plot the points, just because I don't want to be bouncing back and forth and having the audio cutting in and out making this video. All right, so the next thing we want to do is now take the two given points in this problem here, and we want to use those 2 points to approximate the linear relationship between calories and cholesterol. So once again, I'm going to use m, my slope. And again, that's my y2 minus y1 over my x2 minus x1. And I'm going to just label the first ordered pair as x1, y1, and the second ordered pair50, y2. And now carefully substitute those numbers in and calculate down to an answer. So that's going to be 50 minus 70 over 420 minus 560, which simplifies down to negative 20 over negative 140. That is 1/7, but again, we're going to be talking about decimals here, so let's just make that 0.014. No, there's no zero there. Maybe back that up. So that is going to be 0.143. Or, yeah, that's a good enough way to describe it. Now let's move on to our equation. Again, point slope, which is our friend you'll see here in all of these problems. Again, I can use either point. Let's take the second point because the numbers are a little smaller in it. So substituting in, I'm going to have my y minus 50 equals 0.143 times x minus 420. Distributing that decimal. And again, I really don't want to say equals here because these are now approximations because I have decimals floating around and I'm using rounded numbers. So that's going to be a 0.143x. If I multiply the 0.143 times 420, I get 60.06. And then if I add the 50 to both sides, I end up with my linear relationship, which is y is roughly 0.143x minus 10.06. So that is my formula. And again, they want us to use function notation. So c of x is 0.143x minus 10.06. And again, this should really be a squiggly approximation symbol because we are approximating these numbers here by rounding decimals. Okay, next up, they want us to interpret the slope. Well, the slope is going to be thought about as, again, change in y over change in x. So that's the change in the milligrams of cholesterol over the change in calories. So one way to word this would be for each calorie we have an increase of 0.143 milligrams of cholesterol. And again, there's a whole lot of different ways to phrase that, but that's probably the simplest way to do it. All right, now the next part of the problem, they want us to use our model to make a prediction or estimation. So they want us to make an estimation of how much cholesterol we'll have if our burger has 290 calories. So that's going to be C of, let's see, erase that line in there. That's going to be C of 290, which again is best done on a calculator. That's going to be 0.143 times 290 minus that 10.6 from our equation. And that's going to work out to be roughly 31.41. And again, always a good idea to put units. That's 31.41 milligrams. All right, next up, this part is done on decimals. I recommend that you watch the video here to do the problem. What you're going to do is put the numbers into a table that we have up there, and then we hit and type in this in our decimals line underneath it. It's a Y1 with the little tilde symbol, which is just left of the 1 on the keyboard. M times X1 plus B. And what that does is it finds the equation that fits the best to our points. You'll notice it doesn't pass through any of the points, but the idea is that it's the closest one to all of the data. So when you do that, you're going to get the following answer from the decimals calculator. It is Y is approximately 0.118 plus 4.97. And you will notice if you look back on our previous problem that this is actually pretty close to what we had before. Before we had a 0.143 for our slope. Now we're getting a 0.18, so between 14 and 12, they're pretty close if you round them to the hundredths place. So again, that's the line of best fit. And now if you want to make a prediction with it, you can calculate the number of milligrams of cholesterol from a 660 calorie burger. That's going to be that 0.118 times 660 plus the 4 point, that's supposed to be a plus sign there. Yeah, let me put that in there. Well, let me erase that. How strange. Let me see if I can erase it now. Fine, I don't want to do this, but I'm going to just draw a line through it and say this Y is approximately 0.118x plus 4.97. So I forgot to put the plus sign there, and it looks like just a weird mess there. So plus, and then down here, that 4.97. All right, and if we calculate that out on a little scientific calculator, you get 82.85. Remember, that's 82.85 milligrams of cholesterol. So again, it's a good thing to practice that linear regression in Desmos if you plan on taking more math classes, especially statistics, because statistics has a lot of regression modeling in it. For us, I will tell you, just to kind of ease your mind, you are not going to have to do any lines of best fit or regression on your midterm exam coming up in a couple weeks. We're going to leave it with just slopes and finding equations through lines through just 2 points, not the regression models. And that takes us to the end of note quiz number 5, which is all about functions, circles, and lines.